So sometimes when you're given a linear system of equations in two variables, the coefficients aren't as nice as you want. And for example, they might be decimals or fractions. For example, if we're looking at, let's start that one over. So 0.2x minus 0.3y equals 0.5 is one equation, and then 0.3x minus 0.2y is equal to 0.5 is the other equation. Now, this is pretty nasty, and the best thing to do is to actually multiply each of these equations by a factor of 10 so that we can get rid of the decimals. Remember, if you multiply both sides of any equation by the same thing, you're not changing the equation. So if we multiply this top equation by 10, what it's going to do is going to move the decimal point over for each of these values, right? And similarly, if you multiply the bottom one by the same thing, if you multiply the bottom one by 10, it's going to move the decimal point over 1. So let's do that so that we can create a new system that's a little bit easier to handle. So multiplying the top by 10, we get 2x minus 3y is equal to 5 as the first equation, and the second equation becomes 3x minus 2y is equal to 5. And now this is a little bit easier to handle, right? So now what we have to do is we have to cancel out one of the variables, and it seems like canceling either of them was going to be the same amount of work, so let's cancel out the x. So we want to make the coefficients in the x opposites of each other, or additive inverses. So now if you multiply the top equation by negative 3, notice that this coefficient is going to become minus 6x. And if you multiply the bottom equation by just 2, the coefficient for x is just going to become positive 6. So that way when we add these two equations together, the 6's are going to cancel out, which is our goal. So let's multiply these again and rewrite the answer. Rewrite the system. So rewriting the system, let's multiply minus 3 by every single term. So the first term becomes minus 6x, then minus 3 times minus 3y is positive 9y, equals 5 times minus 3, which is minus 15. Then the bottom equation is going to become positive 6x times 2 times negative 2y, which is negative 4y, is equal to 5 times 2, which is positive 10. So now, the x's, when you add them together, they just give you 0, which means they cancel out. And for the y's, 9y minus 4y is going to give us positive 5y. And then minus 15 plus 10 is going to give us minus 5. So dividing both sides by 5, y is equal to negative 1. Great! So now that we've got y is equal to negative 1, we can plug it in to either equation, because remember, this is a system in two variables, so we want to solve for both, so we know what the full solution is. So you want to plug y equals negative 1 into either equation to get x. So let's do that. It doesn't look like either of them are very different from one another, so one of them doesn't seem to be the clear-cut winner for plugging in y. So let's just plug it into the first one. So we got 2x minus 3 times y, which we know is negative 1, is equal to 5. So 2x plus 3 is equal to 5. And now subtracting 2 from each side, we get 2x is equal to 2, which means that x must be equal to 1. So now we have our x and our y, and we want to write our solution in terms of the ordered pair x comma y. So the solution to this system is going to be open parentheses x, which is 1, comma y, which is negative 1.